NASA's biggest Jupiter discovery just got worse, and the deeper scientists look, the more unsettling the picture becomes, because what was once believed to be a relatively stable gas giant is now revealing layers of chaos, instability, and mystery that challenge decades of planetary science. Jupiter, the largest planet in our solar system, has always been seen as a guardian of Earth, a massive gravitational shield that deflects asteroids and comets away from the inner planets. But recent data from NASA's Juno spacecraft suggests that this colossal world is far more violent, unpredictable, and internally complex than anyone ever imagined. When Juno first arrived at Jupiter in 2016, its mission was simple in theory: map the planet's gravity field, magnetic field, atmosphere, and interior structure to understand how Jupiter formed and how gas giants behave. What scientists found instead was a planet that refuses to fit into any existing model. One of the most alarming discoveries was that Jupiter's atmosphere does not behave like a shallow weather layer sitting on top of a solid core, but instead extends thousands of kilometers deep into the planet, blending gradually into a strange, turbulent interior where gases behave more like liquids and electricity flows freely. This meant that Jupiter's iconic cloud bands, storms, and jet streams are not surface-level features but deeply rooted systems connected to the planet's internal dynamics, making them far more powerful and persistent than previously thought. But the situation grew worse when Juno's gravity measurements revealed that Jupiter may not even have a clearly defined core at all. Instead of a compact, solid center, scientists now believe Jupiter has a diluted, or fuzzy, core, where heavy elements are spread out and mixed with hydrogen and helium across a vast region. This discovery shattered long-standing theories about planetary formation, because gas giants were expected to form around a dense core that later attracted gas, not smear that core into an enormous, unstable blend. Even more disturbing is what this implies about Jupiter's past, suggesting that it may have experienced a catastrophic collision with another massive planetary body early in its history, an impact so violent that it partially dissolved the core itself. As researchers continued to analyze Juno's data, another troubling revelation emerged from Jupiter's magnetic field, which turned out to be far stronger, more irregular, and more chaotic than predicted. Jupiter's magnetic field is the most powerful of any planet in the solar system, but instead of being smooth and symmetrical like Earth's, it appears lopsided, with intense patches of magnetism concentrated in unexpected regions. These anomalies suggest that Jupiter's internal dynamo, driven by metallic hydrogen deep inside the planet, is behaving in ways scientists do not fully understand, raising concerns about how stable the planet's internal structure really is. Adding to this growing unease is Jupiter's Great Red Spot, a storm larger than Earth that has raged for centuries and was once considered a symbol of permanence. Recent observations, however, show that the Great Red Spot is shrinking, changing shape, and becoming taller, extending deeper into the planet's atmosphere than previously believed. While some scientists initially thought this meant the storm was dying, newer data suggests something more unsettling: the storm may be tapping into deeper energy sources, becoming more intense internally even as it appears smaller from above. This raises the possibility that Jupiter's atmosphere is undergoing a fundamental shift, with storms reorganizing themselves in response to deeper changes within the planet. But perhaps the most concerning discovery involves Jupiter's radiation environment, which has proven to be far more extreme than expected. Jupiter is surrounded by enormous radiation belts, created by its powerful magnetic field trapping high-energy particles, and Juno has revealed that these belts are not only stronger but also more dynamic and unpredictable. The radiation levels near Jupiter are so intense that they can damage spacecraft electronics in minutes, forcing engineers to build Juno with a titanium vault just to protect its core systems. Even with this protection, Juno has experienced glitches and anomalies, highlighting how hostile Jupiter truly is. This extreme radiation environment poses serious challenges for future missions, especially those targeting Jupiter's moons, many of which are prime candidates in the search for extraterrestrial life. Europa, one of Jupiter's most intriguing moons, is believed to harbor a vast subsurface ocean beneath its icy crust, but the radiation blasting from Jupiter constantly bombards its surface, potentially altering its chemistry and complicating efforts to detect signs of life. As scientists studied Jupiter's interactions with its moons, they uncovered another disturbing pattern: Jupiter's gravitational influence may be far more disruptive than previously thought. Tidal forces between Jupiter and its moons generate enormous amounts of heat, particularly in Io, the most volcanically active body in the solar system, where hundreds of volcanoes erupt continuously. This intense tidal heating demonstrates how Jupiter can destabilize entire worlds, turning moons into geological nightmares. Even Europa and Ganymede, which may host oceans, are subject to constant gravitational stress, cracking their ice shells and fueling subsurface activity that could be both a blessing and a threat to potential life. Meanwhile, Jupiter's role as Earth's protector is now being re-examined. While Jupiter does deflect some incoming objects, simulations suggest it can also redirect comets and asteroids toward the inner solar system, acting as both shield and executioner depending on timing and orbital dynamics. This dual role complicates the long-held belief that Jupiter's presence is purely beneficial for life on Earth. The more scientists model Jupiter's influence, the more they realize that the early solar system was shaped by Jupiter's migrations, violent interactions, and gravitational dominance, potentially scattering material, disrupting planetary formation, and determining which worlds survived and which were destroyed. Even Jupiter's atmospheric composition has raised new concerns, as Juno detected unexpected concentrations of ammonia and water distributed unevenly across the planet. These findings suggest that Jupiter's atmosphere is not well mixed, contradicting assumptions that gas giants quickly homogenize their contents. This uneven distribution hints at complex internal flows and long-lasting structures that may be linked to the planet's formation environment or to ongoing processes deep within its interior. As researchers attempted to reconcile these findings, they began to suspect that Jupiter might not be a typical gas giant at all, but rather a transitional object, existing somewhere between a classic gas giant and a more exotic planetary class. This realization has massive implications for our understanding of exoplanets, many of which are Jupiter-sized or larger and orbit extremely close to their stars. If Jupiter itself defies simple classification, then the diversity of giant planets across the galaxy may be far greater than we imagined. The situation grew even more troubling when scientists examined Jupiter's auroras, the most powerful in the solar system, which are driven not only by the solar wind but also by interactions with its moons, especially Io. These auroras reveal how energy flows through Jupiter's magnetic environment, and recent data shows that these processes are far more intense and complex than predicted, involving massive electrical currents and particle acceleration on an enormous scale. All of this paints a picture of a planet that is not slowly cooling and settling, but one that remains dynamically active, electrically charged, and internally turbulent even after billions of years. Each new discovery from Juno has forced scientists to revise their models, discard assumptions, and confront the possibility that Jupiter is fundamentally misunderstood. And as NASA prepares future missions, including Europa Clipper and potential follow-ups to Juno, the stakes are higher than ever, because understanding Jupiter is not just about studying one planet, but about unlocking the history of the entire solar system and refining our understanding of how planets form, evolve, and influence their surroundings. What began as a mission to confirm existing theories has instead revealed a planet full of contradictions, one that appears less like a static gas giant and more like a living system of storms, fields, currents, and hidden violence. NASA's biggest Jupiter discovery didn't simply complicate the story, it shattered it, leaving scientists with more questions than answers and a growing sense that Jupiter's true nature may be far stranger, more dangerous, and more influential than anyone was prepared for. And as new data continues to arrive, one thing is becoming increasingly clear: Jupiter is not done surprising us, and whatever secrets it still holds may redefine our place in the solar system in ways we are only beginning to understand.